Airport safety depends on more than aircraft and air traffic control. It also relies on detecting even the smallest pieces of debris on a runway. A tiny object can cause millions of dollars in damage, delay flights, or even lead to disaster. One of the most tragic examples was the Concorde accident in 2000, caused by a small metal fragment left on the runway. To prevent incidents like this, researchers around the world have been developing new foreign object debris detection systems. In Japan, at the Electronic Navigation Research Institute (ENRI), Shunichi Futatsumori and his team set out to create a prototype system capable of automatically detecting small pieces of debris across an entire runway. Their solution? A millimeter wave radar system specifically designed to deliver high-resolution, weather-resistant detection across large airport surfaces. But building this system came with three major challenges. First, the team had extremely limited development time, less than 1 month each year to build radar hardware, assemble millimeter wave circuits, and secure experimental radio licenses. Second, the radar needed to process massive amounts of data, over 1.2 gigabytes per second per radar front end, to achieve the necessary range resolution and 360-degree scanning. This level of throughput demanded FPGA or ASIC level processing. And third, the system required complex, tightly synchronized signal processing, including FFT calculations and coherent integration. Outsourcing this work would have been slow and expensive. The team needed a way to rapidly modify algorithms and experiment with new ideas. The breakthrough came from using NI PXI hardware and FlexRIO technology. With LabVIEW and FPGA-based processing, the team built a working prototype capable of real-time radar analysis. The system uses a distributed radio-over-fiber architecture, where multiple antenna units placed near the runway send radar signals back to a central processing unit through optical fiber. This approach dramatically reduces cost, allows long-distance, low-loss transmission, and simplifies scaling the system across a large airport. At the heart of the central unit is the NI PXI platform, paired with a PXIe-7975R FlexRIO FPGA module and a 16-bit 250 megasamples per second digitizer adapter module. These components provide the power needed for FFT calculations, signal integration, and precise synchronization. The PXI Express bus ensures up to 8 gigabytes per second throughput for transferring processed radar data to the host system with zero data loss. Using LabVIEW made the development process dramatically faster, reducing software development time by 90%. Engineers could write both FPGA and host-side code in a single graphical environment, allowing complex algorithms like 8192-point FFT processing to run more than 10,000 times per second in real time. The team could also easily modify algorithms, add new features, and reuse signal processing code from previous radar projects, something nearly impossible with traditional VHDL-based FPGA development. After a 4-year research period, the prototype system proved highly effective. Testing continues by combining multiple antenna units to expand the detection area, and future plans include scaling the system to cover entire runway surfaces with many distributed radar nodes. What began as a challenging experimental project has now become a strong foundation for a more practical, large-scale FOD detection system, powered by NI PXI hardware, FlexRIO technology, and the flexibility of LabVIEW. With advancements like these, airports can move closer to safer, more efficient, and fully automated runway monitoring, protecting aircraft, passengers, and operations worldwide. This concludes today's video. Thanks for watching. If you're looking for legacy NI parts, calibration services, or more technical resources, head on over to apexwaves.com to get what you need fast. We have thousands of NI parts in stock and ready to ship, including legacy and obsolete modules you won't find anywhere else. And if you found this helpful, don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.